All right, so we're going to work problem number 2. Then we'll go back to number 1. So I'm going to subtract sine on both sides. So I have -3/2 is equal to -1. 2 sine theta minus sine theta is just 1 sine theta. All right, and sine is almost by itself. What do we need to do to get sine by itself? What are we moving? Y'all can just hold your fingers up. We're moving the 1. So we're going to add 1 to both sides. Add 1, add 1. One plus -3/2 is -1/2, because that's 1.5, right? And that is equal to sine theta. So at this point, we just do what we did on your homework last night. But I always want to check, am I using all solutions? Am I just going once around the circle? Am I in radians? Am I in degrees? So my instructions say all solutions and also in degrees. So once I'm done and I find my angles, then I'm going to write plus, not 2 pi in because it's degrees, but 360 in, right? We use 360 because sine's period is all the way around the circle. So now let's go find where sine is -1/2. That's a y value. Looks like a little, 330 because I'm using degrees. 330 and 210. So theta equals 330 degrees plus 360 in, and theta equals 210 degrees plus 360 in. Okay. All right, I want you guys to try number 1. So you get your tangents together and then see what you need to do to get tangent by itself, and then find that on your unit circle. So you'll move your tangent, see if you need to do something to get tangent by itself. So y'all try number 1. We'll see if you get the right answer. Give it a shot. Y'all need me to scroll so you can see the unit circle? There you go. Make sure your cameras are on and that I can see you. Cameras are on and I can see you.
Can you scroll down a little bit?
I think it should be on the top half because it's a positive tangent. But I can. Let me just make the unit circle smaller so you can see more of the whole thing. I can do that too. Where is it? There we go. I mean, that might help a little. I covered up the other one. All right, y'all got it? You think you do? So let's make sure that we have it. There are a couple things we have to remember on this problem because it's tangent. So you added tangent to both sides. So plus tangent. Everybody got that part? Okay, so 4 is equal to 4 tangent theta, because 3 and 1 make 4. And tangent's not by itself, so what do you need to divide by on both sides? divide by 4. And we're looking for when tangent equals 1. Okay, and remember for tangent, you only have to look in 2 of the quadrants. I told you yesterday 1 and 2 were the ones to look in, but I bet you realize that quickly that when the problems are in CUDA, they're looking in quadrants 1 and 4 for tangent, for the negatives in 4 and the positives in 1. So just know that when you're doing tangent problems, if it's an all solutions problem, they're going to be looking in the 4th quadrant. But the tangent is positive for us, but we're doing the first, so that doesn't really matter. Just a reminder for that. So we're going to first quadrant, tangent is 1 at 45 degrees, right? Because when you divide y over x, you're going to get 1. That's 45 degrees. So theta is equal to 45 degrees. And since it's tangent, we don't put 360 in. What are we going to put instead of 360? Only half the circle. Y'all can show me with your finger. 180, yeah. There you go. All right, so those are the questions where you've got variables, not variables, trig functions on both sides, but it's the same trig function and they're raised to the same power. So you can just combine those together. We feel okay on those two? Some reminders about the 360 and the 180 for those. All right, our next type, we are solving our equation between 0 and 2 pi. That means we don't need any 360 in or 180 in. We're just going to look around the circle to find our answer. But if I look at these two problems, I have cosine squared and a tangent squared. So I'm going to have to do some square roots in the process. So that's why these are different, because we'll have to square root some of our problem. All right, so our first one, we want to get the cosine squared by itself. So what do we need to move first? The 1, so we're going to add 1 to both sides first. So 1 is 4 cosine squared theta. And then I'm going to divide both sides by 4. And what do you do to get rid of something squared? What are you going to do to both sides to get rid of something that's squared? You take the square root of both sides, and we remember if you take the square root of both sides, you have to put a plus or minus in the front. So we're going to be solving for that, the positive and the negative option. So we'll take the square root of both sides with a plus or minus. And when you do the square root of fractions, we just take the square root of the top and of the bottom. What's the square root of 1? 1. What's the square root of 4? 2. So we're looking for when cosine is positive 1/2 and negative 1/2. So I'm going to draw an arrow over here so we know that. So we're looking for two things. We're going to solve them both. Cosine is positive 1/2 and cosine is negative 1/2. So we're searching for both of those things. All right, so let's go. We're looking for x values of positive 1/2 between 0 and 2 pi. So we're using radians. X value of a positive 1/2, that's pi over 3. And 5 pi over 3. So our first one, pi over 3 and 5 pi over 3. All right, and then our second one, we're looking for when cosine is negative 1/2. Probably the other side. 2 pi over 3 and 4 pi over 3. So when you have a term that's squared and it's the only square or only trig function in the problem, that's the only one that you see, just get it by itself, take the square root of both sides.
Can you repeat what you just said?
You get the cosine squared by itself, and then take the square root of both sides.
Okay.
Make sure you put a plus or minus in the front because that's going to give you all your answers. If you just did the positive, you would have been missing out on these two other answers. So you've got 4 times where this equation would be true. Okay. Do you want to try number 4 on your own? No? You said no? Go ahead and get it set up to where tangent squared is by itself, and then I'll go from there. So go ahead and get tangent squared by itself. All right, so we subtracted 3 on both sides. So 2 minus 3, that's -1. And then we had to divide -3 from the front of the tangent. -1 divided by -3 is a positive 1/3. So tangent squared is positive 1/3. Thumbs up if we got that part. Okay, and now we're going to take the square root of both sides. And we'll put our plus and minus in the front of the 1/3. So tangent going to equal plus or minus the square root of 1/3. And I'll go ahead and write the square roots on both of those just so we can see. The square root of 1, which is 1. I'm not going to write square root of 1. Put 1 over the square root of 3. So I want my y over x to be 1 over the square root of 3. But I want the positives and I want the negatives. I'm looking for positives and negatives, where the y over x is 1 over root 3. I could rationalize it if I want, but it's actually going to be easier for us to see it this way. So I'm looking for when tangent is 1 over root 3 and also -1 over root 3. That's y over x. So the y's got the 1, the x has the root 3. Okay. Let's go searching. 1 over root 3, is that one of them? Right here, pi over 6. When you divide the y over x, your 2's will cancel. That'll be 1 over root 3. All agree? Okay, there's one. None of those, none of those. Here's another one. Oh, that's not positive, that's negative. The other positive one is here. 1 over root 3, that'll cancel, negative will cancel. So that's 7 pi over 6. Pi over 6 and 7 pi over 6 for my positives. Now we'll find our negatives. I'm pretty sure it's the other pi over 6's. Y'all agree? The other times it's 1 over root 3. I think it's the other pi over 6's. Let's double check. -1 over root 3. Here we go. 5 pi over 6. And -1 over root 3, 11 pi over 6. So with those, a single squared term, get it by itself, take the square root of both sides, make sure you evaluate negative or look for negatives and the positives since you have to do the plus or minus in the front. Okay, good on those with the square roots? Okay. The next kind we're going to do, these have lots of different trig functions in them, and we're going to do some factoring. So if you look at number 5, it looks like a bunch of secant and cosecant mess. So anytime that you've got like multiple sets of variables, they might be different types of things, you want to go ahead and move everything over to one side. So at this point, we're going to do some factoring, but we're going to move everything to one side. If you don't just see one trig function, or if they're not the exact same that you could go ahead and combine, you're wanting to get it to equal 0. Okay, so in this case, we want to move everything to one side. I'll put that on the side. Okay, so I'm going to subtract this 3 cosecant. Are all of my trig functions the same? Nope, I can't combine them all together. So in this case, you're going to look at each term and see if there's something in common we can factor to the front. Do both of those have something that's in common? The first term and the second term. What do they both have in it? Y'all can mouth it. A cosecant? Yeah, so they both have a cosecant. So I'm going to pull cosecant to the front. We're going to factor cosecant theta. I'm pulling cosecant to the front. I'm going to write what's left over. So I have negative secant theta plus 2. Let's pick that up. I need some more space. All right, once you have it factored, now it's kind of like we solve quadratics where we set each factor equal to 0 and then solve that. So at this point, we split it up into 2 separate problems and solve both of those. So we'll say cosecant equals 0, negative secant plus 2 equals 0, solve both of those separate equations. Okay, so once you realize there's a commonality, we're going to factor it to the front, then we're going to set each factor equal to 0 to solve it. Because if that was 0, it would be 0. Or if that whole thing equaled 0, that would equal 0. So cosecant theta is 0. And negative secant theta plus 2 equals 0. I'm going to look on my unit circle in a second once I've solved and gotten the secant by itself. So can we get the secant by ourselves in our head in this equation? You're going to subtract 2, right? And then divide by negative 1. So secant would just equal positive 2. So we're going to look for these 2 things. So we're going to look when cosecant is 0 and when secant is 2. Is cosecant ever 0? To get cosecant, you flip sine over, right? Is there some number that we could flip over, a sine value that I could flip over to get 0? If I flip 1 over, it's just still 1. If I flip 0 over, it's undefined, so that doesn't work out. Cosecant doesn't ever equal 0. So that doesn't have an option there. So we can't find one of those. There is no solution for this part. Cosecant doesn't equal 0 ever. So sometimes you'll get that where there's not actually a way for that to be true. So that didn't work out. All right, and now we're going to look for when secant is 2. Do you guys like looking on the unit circle for secant, or would you rather look for cosine? Do you want to go ahead and write what this would be for cosine and then find that on the unit circle? Do you think that would help you? If you remember to get secant, you just flip cosine over and vice versa. So cosine, we're looking for when cosine is, what do you get when you flip 2 over? What's its reciprocal? 1/2, right? So let's look for cosine being positive 1/2. Sometimes that helps me when I'm looking on my unit circle. Cosine is 1/2. That's our x value at pi over 3 and 5 pi over 3. All right, so for this problem, it's basically 2 problems in one. You get everything on one side, see what the common factor is, and once you pull that to the front, you are going to then set them both equal to 0 and solve. Sometimes you don't get an answer for part of it. Sometimes you get an answer for both. So our final answer would be pi over 3 and 5 pi over 3, because I think we're still just finding between 0 and 2 pi on this. All right, y'all want me to do number 6? You think you're ready to try it on your own? You want to see one more? See one more? Okay. All right, so I'm looking, I have the same trig function, but one's squared and one's not squared. So I can't just combine them together. I need to move them all to one side, and I'm going to see if they have something, if every term has something in common. I'm going to try to factor that out. Does it look like every term's going to have something in common? Yep, and I think that's going to be a cosine. So I'm going to subtract the root 3 cosine theta to this side, just so I don't have, I don't know. I could have done it either way. Doesn't really matter. So 2 cosine squared theta minus root 3 cosine theta is equal to 0. Y'all already said it, but what shows up in both of those? Cosine. So we're going to pull that to the front. I can only take 1 out, even though that one's squared, because that one only has the first power. So then this is 2 cosine theta left, because I can only take 1, minus root 3. So this is just like if I had a problem like this, 2x squared minus root 3x, and I just pulled the x to the front. But instead of x's, we just have the word cosine. All right, so I've got 2 separate problems now that I need to solve. I'm gonna arrow it over here so I have more space. I'm gonna do cosine theta is 0. And 2 cosine theta minus root 3 equals 0. For our second one, I bet you guys could do that in your head. What needs to move first? The root 3, we're going to add it, right? And then what do we do with the 2? Divide. So cosine is going to equal root 3 over 2. So now we look for these things when cosine is 0 and when it's root 3 over 2. Cosine is the x value, right? Okay. X value at 0 is pi over 2 and 3 pi over 2. So that's our first one, pi over 2 and 3 pi over 2. And then our second one, we're looking at root 3 over 2 for cosine, pi over 6, and 11 pi over 6. Questions on those? Move everything to one side, pull a trig function if it's in common to the front, and then split those up and solve them both. So if you can do the solving from last time, then you can do the solving for this part. You just have to do these 2 steps prior. Move it over and do some factoring. And then everything else is just what we did before. I guess I'll write that step. So we moved everything to one side, and then we pulled out a common factor. That was for problems 5 and 6. And we're almost done.
Question, well, in CudaWorks, is there any problems like that you're going to have to find all solutions?
That you have to do the plus 2 pi stuff?
Yes, in like 5 and 6.
I don't think I put any on there because I pulled this right from your homework assignment and just switched the numbers up. So the instructions should be the same as this. But if they weren't the same, you would just write, once you got them, if it was cosine after each answer you got, plus 2 pi n after each answer. So it would be these same things, but plus 2 pi n plus 2 pi n. Same thing over here, plus 2 pi n plus 2 pi n.
Okay.
After all of those answers that you got. All right, 7 and 8 are a little bit different. We do have trig functions. There are multiple things. We've got multiple powers, a squared, not squared. But then we also have one that doesn't have a trig function with it. So there's not going to be something in common we can pull to the very front. But it's not, we can't like get tangent by itself right now. So we're still going to move everything to one side. So when in doubt, just like put it all on one side if you've got a lot of stuff going on. And that's going to help you to simplify if possible. So I'm going to add the tangent squared to both sides on number 7 because I don't like that negative. Okay. And I'm going to write it in order from highest power to lowest power so that it looks like a quadratic. So tangent squared theta plus 2 tangent theta plus 1 is equal to 0. Do they all have a common term? The first 2 have tangents, and the last one doesn't. So it looks like we have some commonalities, but we can't just pull tangent to the front because of this 1 here. Okay? Instead of tangents, right underneath this, I'm going to write this with x's. And then y'all will say, oh, you can factor that. And then once we've factored it, we're going to put the tangents back in. Okay? So I'm going to write this instead of tangents, I'm going to use an x so that it's going to help your brain think, oh, I factored that millions of times. So x squared plus 2x plus 1. So instead of tangent, I just wrote an x. Just so your brain can recognize that this can be factored as well. If you saw something like that, you would write your 2 sets of parentheses, right, to factor. And you would look for 2 things that multiply to 1 and add to 2, right? What multiplies to 1 and adds to 2? 1 and 1. Okay. We can put the x's here if you want, but instead of, we're not using x's in our real problem. What are we using instead? Tangent. So I'm just going to write tangent instead. So I just do that just so my brain can see that this is the same way that this problem is written is like problems I've done before. So you can factor it just like before. And if I multiplied this out, tangent times tangent is tangent squared. Tangent times 1 is 1 tangent. 1 times tangent is 1 tangent. So those together make 2, right? And 1 times 1 makes the 1 at the end. And now we have 2 sets of parentheses that equal 0. We set them both equal to 0 and solve just like we did up above. But since these are duplicates of one another, do you think we have to write it twice? No, we just do it one time. But if they're different, yes, you do have to do both of them. But in this case, we just can write it one time. So if tangent plus 1 is 0, we're looking for when tangent is -1, because we subtracted 1 on both sides. And tangent is -1 at 3 pi over 4. So we do y over x, that's a negative. And I think it's also at 7 pi over 4. Y'all think so too? That's the other negative tangent right here. Or -1 for tangent. 3 pi over 4 and 7 pi over 4. So when you get everything on one side and we have a squared, a first power, and then a no power like this, think in your mind, I'm going to factor that like a quadratic, but instead of x and x, I'm going to put whatever trig function that I have, but I still need my numbers to multiply to the last, add to the middle. Okay? Unless we have a number in the front of our squared, and then it's a little bit different. Let's go ahead and do number 8. I don't know why I'm singing, maybe because it's the last day before spring break. I'm going to subtract 1 at the same time. So does this look like a similar setup to number 7? We got squared, we got first power, we have a number at the end. We can't pull a cosine out of everything, so we're going to have to factor with 2 sets of parentheses. Okay, so if you need to, and some people do, some people don't need to write that down. This is like factoring 2x squared minus x minus 1. Well, that's what we're kind of looking at. What are the only 2 things that multiply to 1? 1 and 1, right? What are the only 2 things that multiply to 2? 2 and 1. I'm going to go ahead and write 2 cosine theta and 1 cosine theta. But I need a -1 in the middle. Let's look about our signs. This makes 1 cosine, and this makes 2 cosine. I need it to be a -1 in the middle. So which of these needs to be the negative, the 1 or the 2? The 2 needs to be the negative, and this needs to be the positive. Okay, so that negative goes here, positive goes here. -2 cosine plus 1 cosine makes negative cosine. 1 times -1 is -1. 2 cosine times cosine is 2 cosine squared. So we did the factoring. That's the, like, not difficult so much, but that's the harder part of this problem than the rest of it. And the rest of it is just solving 2 trig equations. Go ahead and get the cosines by itself on both of those problems. So we're trying to find when cosine is negative 1/2, right? We subtracted 1 divided by 2. And when cosine is positive 1. Did y'all get that? Negative 1/2 and 1, that's what we're looking for? Okay. Cosine negative 1/2 would be 2 pi over 3 and 4 pi over 3. And cosine is 1. That is our x value is 1 at how many radians? When is cosine 1? When's the x value 1? At 0. Yep. So when you have squared, no power, and then, or squared, first power, no power, where we go down like this, you're going to factor it like you would factor a quadratic. But instead of x's, you're just going to put whatever trig function you have there. Most of them, hopefully, will be like this, where you don't have to worry about a number in the front. But sometimes you have numbers in the front that you have to contend with. But just a reminder that you're looking for this product, the inner product, and the outer product to add to the middle number. Just a refresher for that factoring. Inner product plus outer product has to add to the middle term.